Hello everyone, I am Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In today's lecture, I am going to explain about mesh analysis. So what is mesh analysis and what is the necessity of using mesh analysis? So if the circuits are complex, means if there is more than two or more loops, so solving only by KVL is not sufficient or feasible. Or if there is any current sources in the circuit, so KVL does not apply in that sources. And also we can't use KCL also because in the circuit half current source will be there and half voltage source will be there. So in such cases, application of KVL or KCL individually, we can't do it. So in such cases, we'll go to the mesh analysis. So in this method, the current flowing through the planar circuit will be calculated. Current flowing through the planar circuit will be calculated. So what is this planar circuit? So what is this planar circuit means? It should have a plane surface. What is plane surface? Here in the circuits means if the wires are two or more wires are interconnected together or they're crossed together, those circuits are non-planar circuits. Means it should not interconnect each other. So there should be a plane surface. It should not cross each other. Okay, these type of circuits are called as planar circuits. So for these circuits, in these circuits only we can able to find out the value of the current in the circuit. So therefore, this mesh analysis is also called as loop analysis or mesh current method because we are going to find out the value of the current in the circuit. So it is used in a closed loop, so it is called as loop analysis. So loop analysis or mesh current methods are other names of the mesh analysis. So before going to the method how we are using the mesh analysis, we have to learn about the branch. So what is a branch? So branch is defined as a path that connects the two nodes such as it contains the circuit elements. For example, it connects two nodes. Let us suppose this is one node and this is another node. So if suppose one resistor is joining this node and this node. So this is one branch. Okay, here another node. Let us consider this is node 1, node 2 and node 3. Here another resistor is there. Okay, so here 2 and 3, between 2 and 3 another resistor is there, means here this is one branch and this is one branch. So these branches are nothing but the interconnection of these nodes. So we can join these nodes with the help of these branches. So if the branch belongs to only one mesh, then the branch current and the mesh current will be equal to each other. So now let us see the procedure of mesh analysis. So stepwise procedure is given here how we have to solve the mesh analysis. So first thing what we have to do was we have to identify the meshes and label the meshes either in the clockwise direction or anti-clockwise direction. So initially identification is very much important. Means whether we are considering whether the currents are in the clockwise direction or in the anti-clockwise direction. So next one was to observe the amount of the current that flows through each element in terms of mesh current. So we have to observe the amount of current, what amount of current is flowing through the element in terms of the mesh current. So next one was we have to write down the mesh equations by using the Kirchhoff's voltage law and the Ohm's law. So what is Kirchhoff's voltage law? Algebraic sum of voltages in a closed loop is equals to 0. So according to that and also Ohm's law. Where we are using Ohm's law? Near the resistors. So where we are using the resistors? Resistor is nothing but a branch in the circuit. So if we are using the resistor, there will be some amount of loss in the circuit. So that amount of loss will be there in the form of the voltage drop, so that there will be some amount of voltage drop across each resistor. So that amount of voltage drop will be found out by using the Ohm's law. So V is equals to I into R. So according to that, we are going to find out the voltage drop in the circuit. So we have to write down the mesh equations to all the meshes using the Kirchhoff's voltage law and the Ohm's law. So next step 4 was the mesh currents are obtained. Already we got the mesh currents by applying the KVL and Ohm's law in the step 3. We are writing the mesh equations. So according to these equations, in which the mesh equations will be solved here in the step 4. From the step 3 we got already the values of currents, which are nothing but the mesh currents, and the mesh equations will be solved here. So for a given electric circuit, we can able to find out the value of the mesh currents. That means the current flowing through the any element in the circuit can be determined using the node voltages. So now let us see the example how we are going to sort out the mesh analysis. Means, so see the first problem here. So in the given circuit of 90 volts, that means they had given a supply of 90 volts is a battery value, 5 amperes is the current source. So they had given the current source as 5 amperes and the 3 resistors are 9 ohms, 6 ohms and 8 ohms. So using the mesh analysis, determine the current across each resistor and the potential difference. So what they had asked us, they had given us these resistor values, they had given us the battery value, they had given the current value, and by using the mesh analysis, they asked us to find out determine the current across each resistor and the potential difference. So what is how much amount of current flowing across each resistor, and what is the amount of voltage drop which is present across each resistor. Current flowing through each resistor and voltage drop across the resistor values. They asked us to find out. So what is the first thing which we have to do? We have to keep the ground terminal. So this is the circuit which they had given. So in this circuit, up to here they had given in the question. So first we have to keep the ground for the reference. So we had kept the ground. Okay, that is the first step. So the next step was we have to determine the potentials, means nodes. What are the nodes? So VA, VB. So here I had considered VA, I had considered VB, I had considered the VC. So let the potential will be VA, VB and VC. For the ground, the value will be 0 volts. So this is the main part, how we are going to sort out the equations in the or by using the mesh analysis. So if we see here, so we can write down the equation from the above circuit as by using the KVL as plus VB minus V1 minus V2 is equals to 0. Plus VB minus V1 minus V2 is equals to 0. So now we have to write down the values here. Okay. So VB 90, VB means 90 volts. Next V1, V means I1 into R1. Ohm's law. V is equals to I into R minus V2. V2 means here there will be V2. Here there will be V1. Here there will be V3. Right. So here V2 means I2 into R2. V3 means I3 into R3. So here V1 means I1 into R1. So V1, so in the V1 we had written I1 into R1. V2, I2 into R2. But the thing is that here the most important thing which we have to consider was this C is common for, this branch is common for loop 1 as well as for the loop 2. Loop 1 as well as for the loop 2. So for understanding of this briefly, I'll show you a small circuit here. So see here. Let us consider a circuit here. Let us consider the battery is 2 volts here. Okay. Here the resistance value is 2 ohms, 3 ohms and 4 ohms. So here the value is 3 volts. Let us consider like this. So what do we have to do? How we have to solve this? First we have to apply KVL across each loop. So KVL. So here the positive value is there. So here the two cases will come. Here, see I had considered I1 here. Right. So I can consider the loop like this. That is the first point. This loop will be common, same. Okay. But in the second case, it will change. See here, in the second loop, the first case was, see the current I had considered like this. The same current will flow like this. Okay. So the current direction can be taken like this. Okay. That is the first one. The second one was, see we had considered the positive here. If we consider the second case. Okay. From here, actually, how we had considered the current direction like this. So like this, we can consider the current direction like this. At such case, what will be the direction of the current? In such case, the direction of current will be like this, which is opposite to that of the previous one. Both are same. Okay, both are same means we can represent like that and we can represent like this also. That is our wish, but we have to represent how we are considering the value of current. I was considering like this, means how much amount of current is flowing here, it is flowing like this, it is flowing like this. So this is I1 value and this is I2 value. I am considering like this, but we can consider like this also, means see. So here positive will be there, I can take it in the reverse way also like this. Okay, anything is correct only, but I was considering the same amount of current like this, so it is flowing like this. I was considering like that. So now how we can write the equations for this by applying the KVL. So 2 into I1. Okay, up to here it is okay, but this resistor is there na, this resistor, it is common for loop 1 as well as for the loop 2, means loop 1 current is also flowing, loop 2 current is also flowing here. So in such cases, if we are considering the first loop, okay, if we are considering the first loop, then we have to take this amount of current as positive, and according to this current will be negative. Means see here, let us suppose this is okay. So here one direction of current is coming I1. Okay, here one direction of current is coming I2. This resistor is having I1 as well as I2. But how we have to consider, means if I am considering the first loop, means from here to here only, then see I1 value will be positive, right? I1 value will be positive. So according to I1, what will be the direction of I2? We have to consider like that. So according to I1, what will be the direction of I2? So I1 minus I2 will come, because if we consider I1, so with that I2 will be negative, means these both directions are in anti-clockwise direction, means one is clockwise, one is anti-clockwise, so both are opposite. So I1 minus I2 we have to consider. But if we consider the same, for the loop 2, at that time we are writing the equation for loop 2. So at that case we have to consider with respect to I2. So with respect to I2, I1 will be positive at that time. So we have to consider like that. So for what loop we are writing down the equation, we have to consider that loop. Based on that, we have to sort out the value. So see here. So now see properly. So let us consider this is 2 volts, this is 3 volts, this is 2 ohms, this is 3 ohms, this is 4 ohms. Okay. So now I1 is flowing in the circuit. The same current, some amount of current is flowing like this, some amount of current is flowing like this. Okay. So current, this is current I1, this is current I2. Current I2. So now I am writing the equation for this loop. So what will be the equation? 2I1 plus 4 into, because this 4 ohms is having the current I1, having the current I2 also, means I1 current is flowing in this 4 ohms, I2 also is flowing through this 4 ohms. But the thing is that we are writing down the equation with respect to I1. I1 minus I2, again if we consider here, minus 2 is equals to 0. Minus 2 is equals to 0. That is for first loop. Okay. If you write down the equation for the second loop, so what will be the equation for the second loop? 3I2 plus 3 plus 4 into, we are writing down the equation for loop 2 with respect to I2. So here I2 is taken as positive and I1 is taken as negative. I2 minus I1 is equals to 0. So if we sort out these two equations, then we can able to sort out the value of the currents I1 and I2. If we elaborate these equations and if we solve these equations, we can get I1 and I2 values. Okay. So the same I am applying here also. So here see 90, this is V1, V1 means I1 R1, V1 means I1 R1. Next R2 means V2, V2 means I2 R2 actually. Okay, this is R3 V3. So if individual resistors is there, no problem will arise. The problem will come whenever two currents are flowing in the circuit, means for the medial of the resistor. For this case only the problem will come. There we have to sort out very carefully. Okay, so minus 90 minus 90 minus I1 R1 minus, so I1, here we are writing down the equation with respect to I1. So I1 minus I2 into R2. Okay, I1 minus I2 into R2, because we are writing down the equation with respect to I1. So with respect to I1, I2 is negative. So I1 minus I2 is equals to 0. So now substitute all these values. So 90, I1 means how much? I1 means I1 only. We have to find out that only. R1 value we know that as 9. Okay, minus R2 value. How much is R2 value? 6 into I1 minus I2 is equals to 0. So we got this equation. So keep this equation aside. This is first equation. Okay. So, okay, we can reduce this equation also. So by dividing with minus 3, we will get the final equation. Okay, 5I1 minus 2I2 is equals to 30. So let us consider this as equation 1. Consider this as equation 1. So with this the first loop was completed. Means up to here derivation was completed. Now we have to sort out for second one also. So how we can going to sort out? See, here there is a voltage source. So that's why we had applied KVL in this particular loop and we had sorted out the equation. But here in the second loop, here there is a current source. So if there is a current source, so the value of the current will be directly taken from the value of the current source. So here, see here, I1 is flowing here. That's why the I2 direction also like this only. I1 is flowing here. So I had taken the I2 direction also flowing like this only. So while flowing like this, but the current direction is like this. Means these two are opposite directions. Okay, both are in opposite directions. So for opposite directions, the value of the current will be equal to this value only, but the sign will be different because both are in opposite directions. If both are in same direction, means for example, if I consider the current like this, then this current and this current source is in same direction. So that we can consider as directly I2 is equals to 5 amps. But here the current value is like this, the current source value is in opposite direction. So I had considered it as I2 is equals to minus 5. I2 is equals to minus 5. So we can substitute the value of I2 in this equation. Okay. So 5I1 minus 2 into minus 5 is equals to 30. So with this we can get the I1 value. So 5I1, 2 5s are 10 is equals to 30. So 5I1 is equals to 20. 30 minus 10, 20. So I1 is equals to 20 by 5 is equals to 4 amperes. So finally we got I1 is equals to 4 amperes. We got I1 is equals to 4 amperes. So we got I1 value as well as I2 value. What is I1 value? I1 value is 4 amperes and I2 value is equals to minus 5 amperes. If we know the I1 and I2 values, we can easily find out the values of as well as voltage drops. So how we can able to find out? So VA means directly the value of voltage is there, that is the value here. So VA is equals to 90 volts. Okay, now VB. So VB is equals to I2 minus R2. So VB is equals to 54 volts. So we got VB is equals to 54 volts. So at VC, we can find out the value of V3. So with that we can find out the value of VC also. So we can able to find out the voltage drops of each values. We can able to find out the voltage drops of each values whenever if we know the values of the currents in the circuit, I1 and I2. So like this we should be able to solve the mesh analysis problems. So what are the disadvantages of this mesh analysis? So if the circuit is lengthy, if you are having, here we are having only 2 loops, okay, so that we had sorted out very easily. So if we are having multiple number of loops, then solving will be a little bit difficult. And also it is used only for the circuits when the circuit is planar. If the circuits are interconnected, means if the wires are interconnected or if there is any clumsy in the wires, if the circuit is non-planar circuit, this mesh analysis is not applicable. So these are the limitations of the mesh analysis. So in the next video, we'll see about the nodal analysis and problems on nodal analysis. Thank you.